So now we're going to talk about energy. So scientists define energy in a specific way. Energy is the capacity to do work. The capacity to do work. Well, what's work? Got to define that too. Work is the action of a force through a distance. So if I take my cup and I push it across the bench, I have applied a force through a distance. I did work on the cup. Now, did anybody pay me for that? No. So it's not work in the sense of you're doing a task and someone's giving you money for it. It's the action of a force through a distance. So here, this guy pushing a box across the floor, he is doing work on the box. Now, if he pushes on the box and the box doesn't move, he didn't do any work. It's got to move.
But there's still energy.
There's still energy, yes. So energy can be divided into different categories. The two broad categories are kinetic energy and potential energy. So kinetic energy is the energy of motion. Potential energy is associated either with position or with the composition of an object. Here in this picture, we have a 10-kilogram weight sitting on top of a building. It has high potential energy because it's elevated above the ground. The higher it is above the ground, the higher its potential energy, the energy due to its position. Because if you give that a nudge, it's going to fall, right? As it falls, it begins to move faster and faster. The potential energy, which is decreasing as it's getting closer to the Earth, is being converted into kinetic energy because it's moving faster as it gets closer and closer to the Earth. We can transform energy from one form into another, potential energy into kinetic energy and vice versa. What happens when it hits the ground? Bam, right? You don't want to have your toes under that, do you? If it's just hitting concrete like this, there may not be anything obvious to our eyes that has happened, but that energy has to go somewhere. And so it could be converted into heat. So high potential energy things are typically unstable, and they will change in a way to become lower in potential energy, which is a more stable position. And this idea is a driving force behind many chemical reactions.
So what would be something else be potential energy?
Well, another potential, we'll talk about that in just a minute, a different form of potential energy. So a subcategory of kinetic energy is thermal energy. So we talked about the solid state of students and how you're all moving even though you're not roaming around the room, right? Thermal energy is associated with the temperature of an object. It's the kinetic vibration of the particles, okay? So right now, you're at a pretty low temperature. If you all started to get all crazy and hyper, and maybe we put on some great music and you're all chair dancing, right? Dancing in your chair, you're not moving around, but you are moving a lot. That would be equivalent to a higher temperature of a solid. The particles are moving more. Okay, so that's thermal energy. Yeah, that's where we're going to get to your question. So energy is conserved like matter and mass is conserved. So energy cannot be created or destroyed. All the energy in the universe is all the energy there ever will be, and we're not going to lose any of it either. So you can't create it or destroy it. It can change from one form to another. Energy can flow from one object. It can be transferred from one object to another object, but the total amount of energy is constant. Objects that have high potential energy tend to be unstable. So what is a different, what's another example of potential energy other than the position? It's the composition, and that's called chemical energy or chemical potential energy. And this comes from the electrostatic forces between the charged particles that make up the atoms and the molecules. So that it's a potential energy, it's due to the composition of the substance rather than to its position. I think we all know that gasoline contains energy, right? Not because we're holding it above our heads and it could fall down, but because of the way the molecules are arranged. Because what happens to gasoline when you give it a spark and some oxygen? It burns. Under certain circumstances, it can explode, right? Where does all that energy come from? It was stored within the molecules. So in your car, you put, if you have a gas car, you put the gasoline in the tank. The gasoline is high in chemical potential energy. It's unstable. And so in your car engine, it's reacting with oxygen, undergoing a chemical change. That potential energy is converted into kinetic energy of the car moving. Does all the energy go into moving the car? No. Some of it goes into heating up the engine, right? The engine gets really hot when it runs. Why is that? Because the process of converting the chemical potential energy into kinetic energy of the car is not 100% efficient. You don't get all the energy out. Some of it gets transferred into heat energy, which just goes out into the atmosphere, right? It just dissipates into the surroundings. It's not that it is lost. It's still there. The energy of the universe is constant, but it's lost to us as being useful. It's no longer useful to us. So there's exhaust that comes out the back of your car, and that's the molecules that are left over after the gasoline has burned. These have low chemical potential energy. They are more stable. So we've gone from an unstable position to a stable position.
So like your battery in the car would be another chemical potential energy?
The battery in a car or the battery in anything is also chemical potential energy. And when you charge a battery, you lose some of that energy. It doesn't all go into the battery. And when you discharge a battery, some of it is lost to heat as well. Yep.